What's up, YouTube? In today's video, we're going to be looking at the solution to the first unit testing challenge or exercise, which is the level 100. Now, even though it's a level 100, there are some complexities and challenges, and I would like to go through that and then provide you with the solution. The link to the solution will be in my GitHub, and the link will be in the description below. So let's just look at the solution. Okay, first up is how do we arrange for this scenario? So you can imagine, and I'll show you the config file. So this is what the appconfig.json file looks like. When you're testing this class, in order to set up or arrange for the scenario, you need to be able to conceptually modify this file, right? Let's say you want to set up the email templates path such that the path in the config file does not begin with a backslash. So it doesn't have the starting backslash. That's a scenario, which means for every test, when you arrange for that scenario, you need to have the ability to modify that physical file, conceptually at least, right? In other words, for every one of these properties here in the config file, each of these properties have different scenarios, and you're going to have to be able to modify the file, or let's call it the source of the configuration, because there can be different sources in .NET Core. They make it very simple to have different sources, the JSON file just being one possible source. But you need to have the ability to modify this file to set up or arrange for the scenario. So that's sort of the one idea. So towards that end, I'm going to show you that our production class, the configuration provider production class, in its constructor is using the configuration builder, and then it says add JSON file. And it says use this JSON file as the source of the configuration. So the configuration builder has different sources we can set up. One of them is an in-memory source. Keep in mind, by changing the source, if you will, these are all .NET classes, so we are not necessarily having, if we modify this to say use in-memory in our testing, we don't need to test the .NET source classes, right? So we're only having to test our own classes. Our class is dependent on the fact that this configuration provider or the iConfiguration root does its part, no matter what the source is, okay? This constructor here takes an iConfiguration root as an argument, and it assigns the argument to the private member here, which is both are assigning it to the same configuration root member. Therefore, if in our tests, we could provide it with a iConfiguration root that is an in-memory version, then we can, for every test, arrange for the in-memory source, data source, to have the data that we require it to have for that specific test, and therefore we can conduct our tests. And that's what we do in our method over here, create configuration provider. Oh, by the way, if you never used internals, if you look at all these classes, they are internal, right? Internal sealed. And you must be wondering, how is this unit testing project going to have access to the internals? And it's simple. This is something, the feature of C# since the very beginning, probably .NET 1.1, if probably maybe 2.0. If you look at the program CS file, we have this line here that says make internals visible to, and we have provided an assembly. There could be multiple assemblies. You can make the internals of this assembly visible to. And in this case, I've called it configuration provider.test. So it's important that your test project is called configuration provider.test. If you call it some other name, you're not going to be able to see the internals. You'll never see the configuration provider, and therefore you'll never be able to test it. So if you've gotten stuck there at that step, that's why. And I was hoping, it was a challenge, as I said. It wasn't something I wanted to, sort of lay on a platter. So those of you who probably worked with invisibles, with internals, you would have figured this out. And those who were stuck and were now waiting for the solution to just get going with that, that's the solution. And if you want to now attempt writing the test yourselves, then you might want to pause or stop this video and go back to the other video, or write your test and then come back here and continue watching. Okay, I encourage you to do that. Write the test yourself. If you need help, I'm going to provide some help. I'll certainly provide the link to the solution, but in the video, I'll only talk about one of the properties and all of these scenarios, and that should help you then proceed and implement all of the other scenarios for the other properties. And so you might want to stop there and then do the rest of the tests yourselves and then come back and look at the solution, right? So your test project must be called configurationprovider.test. And as you can see here in the Solution Explorer, my test project is called configurationprovider.test. Now, it's not so much the project name as it is the assembly name. So essentially, if you look over here, it's really the assembly name that's important, not so much the actual project name, right? So it's really the assembly name. But typically, if you haven't changed this value, your assembly name is the same as the project name. All right. Having done that part here, I'm just going to reiterate the requirements for this email templates path. That's the property we're going to be discussing in the video today. And then you guys can do the rest if you feel like taking up the challenge with a little bit of help. And then you can look at the source code eventually. So this email templates path is essentially not optional. So that's one thing to keep in mind. It's not optional, which basically means if the setting is not present or is somehow invalid, the configuration provider is not going to default to some default value. It expects to find it there, and it has to be valid. It can't be missing, right? So that's one aspect here. The second is if the part over here, that email template path always starts with a backslash, even if the value in the config file does not. In other words, this configuration provider's implementation, rather than throwing an exception if it doesn't start with a backslash, will insert the backslash in the start and return that either way. So whether the setting had the backslash in it, the starting backslash or not, the provider will insert that backslash. So that's sort of two scenarios you need to test as well. So it's a required property, and that other feature of inserting that backslash, starting backslash, irrespective of whether the file itself contains a value or not. And because it's not optional, if the value is not there, it's going to throw an exception. And the value is not there could be n number of scenarios, right? Is it null? Is it empty? Is it just spaces? Is the entire setting missing? In my vocabulary, when I say config setting, I'm talking about the entire thing, right? That's the setting. Each of these lines is a setting. So if you see a scenario that says the config setting is missing, it means that this entire line is gone. It's not there, right? And it's important to establish a vocabulary within your team because everyone needs to be speaking the same language and have the same understanding. So one of my managers in the past used to say it needs to be well known and understood. Of course, his context was different, but I've liked that term, so I'll use the same thing within my teams. It has to be well known and understood. Well known across the team and understood by the same understanding across the team. Okay, so let's get started with the actual tests. So actually, let me explain this part here. So this private static method here is essentially going to create for us an instance of a configuration provider, the production class. But because we want that configuration provider to be provided in its constructor with an iConfiguration root, that is an in-memory version, and we want to be able to set up the iConfiguration root to have certain data that we want it to have for that specific test. Every test method is going to call an instance of call this method to get its own instance of a configuration provider that has been set up specifically for its scenario. Now, it also becomes important to do this sort of thing when you are working with your tests in a multi-threaded setting. In other words, in Visual Studio for many years now, many versions, we've had the ability to run tests in parallel. So, and they keep changing what it means to be parallel. And I won't go into the details of that, but nonetheless, is the potential of each of these tests, every test method could be running simultaneously. Therefore, you can't share the same configuration provider instance. You want to make sure that every test method gets its own instance. So basically, every test method will call this argument. If you're wondering why this is returning a configuration provider base, this is essentially programming to interface and not implementation. If you have not heard me talk about it, but you think you know about it, I suggest you take a look at this video over here. I think it's the polymorphism one. There's also another one on, I think, the factory method pattern, where I talk about in more detail the meaning, the true and proper meaning of program to interface and not implementation. But I won't go into that here. All right, so let's look at the first test method. the first test method. Now, again, just to reiterate the way these test methods are designed. These test methods are broken up into 3 parts. Each part is separated by an underscore. So there's 2 underscores, therefore there are 3 parts here. The first part is the feature. I'm trying to highlight just the first part here. Is the feature you're trying to test, or the method you're trying to test, or the property you're trying to test, right? It's essentially what is your testing. It could be a feature of the system, or it could be a method of a class, or it could be a property of a class. So that's the first part. The second part here is the scenario. Now the scenario and the expectation, the last part being the expectation here. The scenario and the expectation need to be in business terms. Okay, it's refrain from making it too technical. You don't want names to start becoming technical. Now, even though the configuration provider is a technical class, as in the business couldn't have possibly told you to use a configuration provider, to have your settings in there. But just keep it more business-like. So rather than saying, let's say, for example, something should return, and I don't know how to give you an example right now, but keep it business-like rather than technical. I mean, every method in your system should really be more business-like. I mean, when I say business-like, I don't mean because you're building a business system. I'm saying the business of, if you're building a game, it should be in the language or the vocabulary of the game rather than a technical thing. All right, so that's what I mean by business. Okay, so the first scenario is when the config setting exists. So setting, remember config setting, I mean that line. The config setting exists and it is set up correctly. In this case, it just means it's been set up with the starting backslash. Returns the expected value. So that's the expectation and the scenario. So variable names in these cases is very important. And there's I guess a convention that I've seen a lot of people employ, which is the expected and actual. So this is the expected email template. And we set up this value, and this value has the starting backslash. So it's the expected email template. And when we call the property, or when we access the property, we get the actual email template, right? So there's the expected and then there's the actual. In the arrange, you will set up all the expecteds, and in the act, you'll get back an actual, and in the assert, you'll assert the expected against the actual. Now, the reason the expected is the first thing here is because, as you can see here, the first argument is expected and the second argument is actual, right? So don't ever interchange these two things. It'll be really, really confusing and you'll get confused yourself. Always make sure the first is the expected and the second is the actual. Even if you are building your own methods where you did the assertions, make sure the first argument is expected and the second argument is actual. And any other arguments you might need are after the expected and the actual. All right, so at the time of calling this method, we get the opportunity to tell it, give it a name and a value, which is essentially the key, the configuration setting key, and then the value to the key. So I have a few constants set up over here for the different keys that we have in our config file. So we are working with this one, the email template paths key, which is nothing but this thing, which is the same as what you see in the JSON file. This is for this key, set up this value, which is the expected. And once that's done, we get back a configuration provider instance. We access the email templates path. We get back an actual, and then we assert the expected against the actual, and they're supposed to be equal, right? So that's what we're testing here. Now, most of these asserts, if not all, have a third argument that allows us to provide a message. This is a message that will be shown to us if this assertion fails. In other words, when your tests fail, when your test fails, then you will see this message. In other words, this message is really for you. When you are, imagine the scenario where this stuff is running on a build server, so you don't have access to the build server. You can't get onto it. You can't see much of anything except for, let's say, a log or the error message itself. If this test fails, what would you like this message to be? Now, take your time about these messages. These are really important. It's important to be able to discern the exact problem by simply looking at the exception message. You shouldn't have to find out that a test or few tests fail on the build server, and then you look at each one of those stack traces. Then you have to start doing the whole thing back on your local machine to figure out what is the real problem. Save yourselves time and headache by writing these messages in a way that will help you decide or understand almost instantly by looking at the message, what is the problem and how you would probably fix that problem. Okay, so that's the third argument here. So we're saying over here, we were expecting the actual email template path to be this, but we found it to be this. And that's pretty much what we do in this simple case. So this is the first scenario. The second scenario then is when the config setting exists but does not start with a backslash. Returns the value with the starting backslash, because we know the configuration provider will do that extra work there for us. So here we've set up the email template path to be this. This is the email template path. This is the value, which is without the starting backslash. And this is the value we're going to have our configuration provider method, or the one that creates the configuration provider, to set this up as the initial state of the source of data, if you will, for that key. And we also set up the expected in the arrange portion. We set up the expected to be the starting with the backslash and then whatever that value was. So even though we've set this up to be the value in the config file, this is what we are expecting because we know the behavior or the expected behavior of the configuration provider. Then we call the act, where we access the property of the email templates path. And then again, we do the assertion against the expected and the actual, and we provide that message. So the messages in these two cases are similar. So that's the second scenario. The third scenario is when the config setting exists, but the value is empty. Now again, empty means it's what we would consider, you can say blank typically if you want to be more business-like. And that's what I mean by technical versus business-like. Empty is something we understand. Not everyone understands what does empty mean. So when you say blank, most people understand that blank would mean like there's nothing there. And so we set up the value to be blank. And notice also I've used the named arguments feature of C# so that when you see string.empty just by itself, you're not confused as to what's really being set up. So you can see here is the app settings value is string.empty, whereas the key is this key. And then because we are expecting an exception, all right, because we're expecting an exception, there are a few things we want to do when we are testing for exceptions, meaning we're testing to ensure that that class or that thing, the system, is throwing an exception under a certain scenario or certain condition. One, we have to ensure that the exception is thrown. If the exception is not thrown, we want to ensure that we fail the test, right? Because otherwise you're going to get a false positive. I know it's a little confusing, or it could get a bit confusing if you've never done this before. When you're testing for a system to throw an exception, as in you expect it to throw an exception, if it does not throw the exception, you want to actually fail the test. But if you don't take measure of your own accord, if you don't do something extra to fail the test will actually pass, which means you got a false positive, right? So I have a private field here in this test class. Now, this same method, if you're writing this in a large system or any system that has more than one class, or where the system has many exceptions to be tested across different classes, then this will probably be in a shared library of sorts where you won't repeat this in every test class. But since this is a small example here, I've got it in this method itself. If you're not familiar with higher order functions, then I have a video that I can point over here, delegates and higher order functions. You might want to look at that video to get a better sense or a bit of more comfortable with higher order functions, because this is using a higher order function. But essentially, I want you to look at the implementation here. So we will provide it with a method to execute or a property to access, and it does that. So this is the act, if you will. And if this act does not throw an exception, that's a problem, which means it's going to go to the next line. It won't go in the catch block. It's going to come here, and over here we want to make sure we fail that test. And we're saying over here, we were expecting a configuration settings exception to be thrown, but no exception was thrown. And if the exception is thrown, so that's certainly not a problem. You want to make sure you're catching the right type of exception. You don't want to catch exception, right? So over here, you can see we're catching the same type as was provided as the generic type argument here. So it's not a generic type, it's a specific type. Yes, it's a generic type argument, but what I mean by generic is it's not the base exception class. It's a very specialized exception class that you provide in from the call site. Now, that exception could be thrown for many reasons. How do you know it's been thrown for this specific reason or this specific scenario? So typically, the exception messages will be different, indicating different problems. And so you can look at certain keywords or look for certain keywords inside the exception to ensure that, yes, this type of exception was thrown, which is good. And the message contains certain keywords you know will only exist for this scenario, right? So that's really the purpose of this method here. And this method, of course, is in order to validate that part, is calling another private method here. You can look at the implementation. I won't explain the actual implementation. It's very simple, but I will just explain to you what this method is really doing. So going all the way back up to the top, if you look at this method over here, going back to this, when the config setting exists but value is empty, we expect an exception to be thrown. So we are using this method, and I've marked it as act and assert, so sort of doing both. This is the act portion, as in this method or this property will be accessed, or this method, if it were a method will be called. And when this property is accessed, we are expecting this exception to be thrown, or this type of exception to be thrown. And we are expecting these sort of phrases or keywords to be present. All of these, not some, all of these keywords to be present in the message. So that's really what we're saying. We're saying we expect to find the email templates path to be in the message. So we know it's for this problem. It's not for something else. And we know that this exception is being thrown because it's empty and that is required. Right? So that's what we're looking, and you have to pick and choose the keywords that you want for your specific case, specific scenario. It'll probably also help you write sort of specific exceptions for those specific scenarios. So you don't use a generalized message and a generalized exception for your exceptions. Now, this is probably the only time or only place in my entire system, for any of my systems, where I will use the same exception in multiple scenarios. And this will be only in my configuration provider. I'm not sure why I do that. It's just sort of, I guess, something that I've been doing for years, and I continue to do it and never had a problem with it. But any place else in my system, I will have highly specialized exceptions. For every little scenario, I'm going to have a different exception. So don't shy away from creating specialized exceptions for specialized cases and scenarios. It's not about a class, or it's not, like in this case, it's all in one class that I use the one exception. That's not how it works. If you want to, you can have specialized exceptions even for this class and see, how that feels if you want to try that out. All right, moving on to the next scenario. It says when the config setting. So again, config setting is the sort of the vocabulary I use to indicate the setting, the entire kind of the line, if you will, right? So when the config setting exists, but value is white spaces. So white spaces, this is different from empty. And so I've set up the config data to have white spaces for this key. And again, I'm expecting an exception of the same type. At the time of accessing this property, an exception should be thrown. If it is thrown, it's going to ensure that the message contains these keywords or phrases in it. And if it has to contain all of them. It's not like some of them, it's all of them, right? So if any one of these is missing, you'll get an exception saying, hey, an exception was thrown. However, we were looking into this message and we were expecting these phrases, but this phrase or these phrases were not found. So the messaging is fairly detailed. So you're not thinking and guessing to see what's happened, right? That's all happening in those two private methods that I showed you earlier. Then the next scenario is when config setting exists, but value is null, right? So there was empty spaces and now null, value is null. So you can see that happening here. And again, the same thing, we're expecting an exception and blah, blah, blah. The only difference is like now it says is missing and value is missing as well. And okay, so there's three arguments. So three phrases we're looking for here in our messages, in this case, in most of the cases here. All right, then the final scenario is when the config setting is missing, right? So since I've been saying config setting means the entire line, it's not like the one piece or the other piece, not the key or the value. So when I say config setting is missing, then I'm saying that the entire line is not there. In other words, if you look at the JSON file, this is what I mean by missing. So here's the line and that's missing. It's not there, right? So that's what I mean by missing, at least in my vocabulary. And I've been using this for many, many years across many, many teams. As I said, it's important to establish a vocabulary. In a team, the language you speak, and I don't mean English or French or German or whatever, but what I mean is your vocabulary, has to have meaning so that the entire team is on the same page. So it's important to establish a vocabulary, for the technical things. For the business side of things, you want to use the business's vocabulary within your team as well. So we have, what's that one? Let me count from the top here. So we have 1, 2, 3, 4, 5, 6 tests for that one property, 6 scenarios and expectations for this one property to test this one thing. Now, in this case, the property is required. There are other properties in the configuration provider where they are optional, and the behaviors are very different in each of the properties. That was sort of by design, and that's why I built this unit testing exercise in the first place. There's another case I want to show you. I won't go through all of these, but I want to show you another case. Right, this notify uploads is a Boolean. Let's look at the sort of the requirements of this property here. So it says that this property is optional. So first of all, it's optional. In other words, if it's not there, it's okay. The setting is not there, it's okay. If the config setting is found, this property should return true. If this config setting is found, this property should return true. If the setting is not a valid bool, then it should throw an exception. I think there's a mistake here. The setting is, if no config setting is found, the property should return true. In other words, that's the default behavior of this thing. If there's no setting, it'll return a true, right? But it's optional, so if it's not there, that's okay. It's just going to return a true. Otherwise, it's going to return what's in the config file, unless what's in the config file cannot be parsed to be a bool. So if you, I don't know, wrote like a T or yes or something, it's not going to work. So even though it's optional, if you misconfigure the value, it's not going to work. But because the default is true, the first test over here I have is when config setting has been set to false, should return false. This might sound odd, but if you think about it, you'll realize that if it's returning true by default, how do you know it's returning true just because you set it up? Right? Now, of course, there could be so many nuances to that whole thing as well, but I want you to think in those terms. I'm going to set the value to false and I'm going to expect a false. I'm going to set the value to true and I should expect a true, but that's not quite testing anything in this case, or may not be testing anything in this case, because the default behavior of that property is to return true. So you may not have been testing anything, right? So that's why I've set it to false instead of true. That way I can see that if it's set to false, it returns a false. Now you could say, well, then you should have a set to true and returns true. And then also if it's not set, it should return a true as well. And though, yes, that's a valid test as well, except I've not done that here, I don't think. Yeah, this is what, with teams and people, talking about these kind of things, scenarios together, you arrive at the more specific tests or all the tests that are required to be in place. And it's important when you're deciding what kinds of tests to write for a certain system or a class, that you're working with other people on the team who understand the business, who understand the feature you're trying to build or whatever it is. So you're working together to decide what those tests need to be, right? It's not a single person thing, because anyone can easily miss a scenario, not having thought about it. So, yeah, so that's all I wanted to show you about this specific property, because it's a little bit of a nuance and I want to explain that nuance. And there's many other nuances as well there. So, well, I think that brings us to the end of this. I'm not sure. I'm hoping I've not forgotten anything, but the source code will be there with you. And again, please, if you have not started yet, use the basic explanation I've given in this video to get started and try writing the test methods for these tests I just explained, and plus the others, just to get a sense of what it takes, right, to write these tests. There's a bit of a challenge in each of those tests. It'll be, it'll be nice to get past that. Now, the next step is, sorry, I forgot, there's more. The next step is to run these tests and look at the code coverage. So I'm going to run the tests and I'm going to show you the code coverage, just so for those of you who don't know or have never, have not seen how to get code coverage in Visual Studio. Now, I believe code coverage analysis is not available in all versions of Visual Studio. So I don't know for a fact what version they are. So if you don't have code coverage in the version of Visual Studio you're using, then I'm sorry, but I'm not sure there's not anything you can do about it. But I think every year they change the community edition to have more and more features. So I don't know. Anyway, to run, you'll see all the tests over here. And then to run the test and or get the code coverage analysis, you just do that. And in a few seconds, and it has to build the entire solution and the test first. And now you can see here that it is showing the code covered blocks is 100%, not covered blocks percentage is 0. So in other words, you got full 100% code coverage. Now, please don't chase code coverage. You should aim at all times to get 100% code coverage. You may not get there, but don't chase it in the sense that you don't writing tests to get code coverage. None of these tests was written, or all of these tests were written, and then I looked at code coverage, right? I don't look at code coverage while I'm trying to decide what test to write and what scenarios to write. It's important to write tests that test that class of the system, not about chasing code coverage. A lot of people chase code coverage. I know in some organizations, you're gauged on code coverage, or you get dinged if you don't have the right amount of code coverage or whatever. That's unfortunate, but don't chase code coverage. But certainly aim for 100%. Or if you can't ever get there, then maybe if you can't explain why you can't get there, then that code is unnecessary. Just take it out. I mean, seriously, I've done that in many, code bases of mine. We typically tend to what I call gold plate. It's called gold plating. So we typically tend to gold plate our code. We add all the bells and whistles and the frills to some code we write because we think we can use it in 15 different places. And so now you got all this code that is never used in this system. Take it out. Don't leave it there unnecessarily. If it's not being used in the system, it doesn't belong in the system, right? You can use GitHub these days or Gist or whatever to keep that code and put it on a pedestal at some point, but it doesn't belong in the system that you're trying to build now. And certainly lower code coverage percentages are indicative of the fact that you don't have enough tests. So there's no two ways about that. Lower code coverage percentage values certainly indicates a problem, meaning certainly indicates missing tests. 100% code coverage does not indicate anything. It does not indicate you finished writing all the tests. This exercise actually is a case in point. You could be reaching 100% code coverage well before you're actually done with this set of scenarios and expectations that you need to test for this class. So I'm pretty sure I'm thinking while I'm saying this. As I said, I didn't actually test it. I wasn't checking out the code coverage, but I just know from the different scenarios that multiple scenarios execute the same code paths, and you're very likely to get 100% code coverage probably while you're about 90% into the scenario. You're missing 10% of the scenario, then you're going to get 100% code coverage. If not in this class, I know it happens in many cases in the real world. So if you stopped when you got because you got 100%, you think, oh cool, I've covered all my lines of code. Well, that's not the right time to stop. It is important to write tests for the scenarios that you know of and the expectations for those scenarios. Otherwise, you're going to miss some scenarios and your system is going to have bugs in production. So anyway, there's a whole thing on my unit testing playlist. I can put a link to it over here. If YouTube allows me only a certain amount of links I can put in. So forgot how many links I'm going to put up here. So anyway, that's all I have. I hope you've enjoyed yourselves. I hope you've learned something and will write the unit tests and then let me know how that went. And if you haven't subscribed, please subscribe. Please hit that notify bell so you get notified each time I upload a video, and I will see you next time.